Hey guys, Mr. Corbin back with you along with Miss Powell. If you did not know it, we are the best eighth grade math teachers in Webster County Middle School.
And because we're the only eighth grade math
teachers. That's exactly right.
We
are the only ones. And so lucky you.
You have the best.
That's right. Lucky for you that we are the best. And so Miss Powell, what are we going to be talking about in this video?
Okay, we're going to go back to basics and look at a multiplication chart. So most kids know how to read a multiplication chart. If I said what's 7 times 8, you can pick 7 on one side, 8 on the other, and where your two intersection points, you get 56. Now, I could have picked the 8 here and the 7 here, but it still comes out to 7 times 8 is 56.
Right.
So that's just how you read it. Now, if you kind of look in the middle, these numbers that go diagonally, they're kind of a little bit darker.
Who just leaves their phone on like that? That is so rude. I don't even know. Do you do that at church too, Miss Powell? I bet you do.
I will actually say that's a church person calling me. Probably about the holiday world trip. Okay.
All right. So again, these numbers that you're highlighting right here, they're special, aren't they, Miss Powell?
Yes. So they're a little bit more bold because they're what's called perfect square numbers. Because now when I take my fingers and read where I get that number, like 25, if I go up, I get 5, I get over, I get 5. So this time it's not like 7 times 8 where the two numbers don't match. The two numbers always match. So if I go to 81, I scroll over and I see 9 times 9 gives you 81. Now, what they call that is they call it a perfect square number because let's say that you are asked to draw a square. Well, there's a difference between a square, and that's not a good square.
That's the worst square I've ever seen, Miss Powell.
Not a good square.
What is that? That's not even, what is that?
That's a rectangle.
That's a rectangle. Certainly, it doesn't even matter.
Oh, it's close enough.
Okay, Miss Powell, where are you going with this?
Let's say that a rectangle is a 15 by 6.
Okay.
So I could take my chart, and I could do 15 times 6, and I get 90.
Okay, we can't see that, but we'll take your word for it.
Okay, take my word for it. So to find the area of that, it's 15 times 6, I get 90, but it for sure is not a square. But on the one that I drew up above, if this happened to be a 9 by 9, that is a square, and I get an 81. So 81 is what's called a perfect square number because it's the perfect side lengths on the square. The square has to have same numbers.
Yes, we know that all of the side lengths in a square are going to be congruent, right?
Right. So they came up in math a way of saying, how do you square a number? Well, how you square a number, like 7 times 7, that's how you square it. But in math, a lot of times they like to shortcut it. And instead of putting 7 times 7, they'll put a 7 with an exponent of 2. And that's the same thing as saying 7 times 7, just an easier, shorter way of writing it.
Now, Miss Powell, I know for a fact that sometimes people will say, they'll look at this real quick, students will, and they'll go, oh, 7 times 2, well, that's got to be 14.
Yeah.
So you got to be real careful right here. When you square something, you're multiplying the base numbers times itself twice. Just like if it was 7 cubed, it would be the base number times itself 3 times, okay? And that number 49 now is a perfect square.
So I'm going to call 7 the base, and it's the sides of the square, basically. Well, the little 2, instead of saying 7 to the power of 2, this is a little exponent, but you could, with the power of 2, say it's 7 squared. That's just another way of saying it. Which again goes back to square squared. And this comes out to be my answer 49, which is basically the area of the square.
Right.
So sometimes they want you to take the area of the square and figure out what the sides are. So just like they came up with the symbol here, they created a symbol to let you go backwards. And that symbol is the little check mark thing. That's called the square root. So if I put in the square root of 49, I'm basically asking you what number do you multiply by itself to give you 49.
So when I see the square root symbol, the check mark, okay, it's unsquaring a number. It's going backwards from where we squared. If you go back up here to the top where you have this, You moved my stuff.
Oh,
Why'd you
so
move my
sorry.
stuff,
Okay,
Miss
there you
Powell?
go. This
When
is,
you square, when you have the 7 squared, how do you get 49? How do you unsquare 49? Well, you, just like you said, you're asking yourself what number times itself gives you 49. And so obviously the answer to that is 7.
now, since we're not squaring it, they put an extra word on it and it's called square root. And that's the little check mark. And your calculator has a square root button on it. You hit second, and if you pay attention to where it's at, it's above the x squared because they're opposites each other. And you put in 49, and that gives you 7.
And that's probably a pretty good thing just to know on your calculator. All calculators are different, but I know with these Texas Instrument ones, when you see the little blue key and sometimes it's a little lime green key, that always means the second function, which is the what's above the key. And so it'll be the same color as whatever your second key is.
Now, if I ask you to find the square root of 169 and you have a multiplication chart and it's one of those bolded numbers, you can scroll up and over and figure out what the square root of 169 is without a calculator, which basically is 13. Because 13 times 13 is 169.
So again, that 169, it has a special name to it, right, Miss Powell?
Yes.
And it's called a perfect square. We talked to you guys a little bit about that in the other video when we first started talking about rationals and irrationals. The square root of 169 is 13, and because it comes out as a whole number, it is called a perfect square. Now, Miss Powell, when we were talking about rational and irrational numbers, would this be rational or irrational?
Well, it'd be rational because you can take the 13, since it's a whole number, and write it as a ratio. Now, here's going to be the tricky thing. Let's say that I ask you for the square root of 11. Okay, 11 is not a perfect square number, but I can find where 11 would fall. 11 falls in between 9 and 16. So just by looking at where the 11 would be, then I look up to the two numbers, and I know the square root of 11 should be between 3 and 4. So I'm going to take my calculator and test it. So if I take the square root of 11, I should get a number that's between 3 and 4, and I get 3.31662479. Now, if I try to ask the calculator to turn it into a fraction, it won't, because this is an irrational number. So when I put equal earlier, then it meant equal. But I'm going to put two squiggly lines because it's not equal to this number, but it's close.
It's approximately.
So, and the reason why I can't say equal is because when does this decimal end?
Well, we just have to put 3 dots at the end because it keeps going, right? And again, this is an irrational number. Irrational numbers are decimals that have no end, okay? They're non-terminating and they're non-repeating. And I know that that square root right there, 11 is not a perfect square. The only rational numbers in square roots are the perfect squares. And so you can look at 11, you can say, well, I don't know of anything times itself that gives me 11. So I know this is going to be a non-terminating, non-repeating decimal. And so automatically it's an irrational number. And so that's what you got to think to yourself. Is this a perfect square? No. Automatically it's going to be irrational. Okay. And I love it, Miss Powell, that you put those little squigglies right there, because this number continues on. And that's why you put the squigglies, is because it means approximately that number.
Okay, so let's say that I don't have a calculator handy, but I do have my multiplication table. And the question says, where does the square root of 60 fall? So at first, you want to just find the two perfect squares that 60 falls between.
Well, first of all, Miss Powell, before you start that, is 60 a perfect square?
No.
There's no number times itself that gives me 60. So I know this is going to be an irrational number. Now, what Miss Powell's getting ready to teach you is how do we approximate that? In other words, if we don't have a calculator, how can we get close to the decimal approximation of this number? And this is going to be important because the next thing we're going to teach you in the next video is how to order these on a number line. And so this is going to be really important for you and certainly will show up on the K-Prep test.
Okay. So square root of 60. So you scroll down this list, and 60 is going to fall in between the 49 and 64. So I'm just not going to put 49 plain. I'm going to put the square root of 49 because it's a perfect square, and the square root of 64 because these are perfect squares and I can find the square root.
So we know those. Again, we don't have a calculator. This is what we're assuming. And so we don't know square root of 60, but we know the closest square root below it that we know is square root of 49, and the closest one above it is 64. Those are the perfect squares, and we know that that's going to be 7 and 8. And so watch what Miss Powell does here.
So I'm going to bring down the square root of 60 because I don't know what it is, but I know the square root of 49 is 7, and I know the square root of 64 is 8, and this fits in between it. Now, I like, instead of just making a list and putting commas between it, trying to tell you the relationship. So 7 is to the left of this, so it has to be less than this. Well, the square root of 60 is to the left of 8, so it means it's got to be under 8. So 8's the biggest thing it could be, and 7's the smallest.
So what you're saying is, Miss Powell, it's going to be 7 point something.
Right.
It's going to be 7 point something. Now, I always, instead of just guessing and multiplying this out over and over and over again, is 60 closer to 49 or 64?
Well, that's where, when you go back up here, from 49 to 60, that's 11 steps.
Mm-hmm.
But from 60 to 64, it's only 4 steps. So if I was going to say where's square root of 60, everybody just says, oh, it's in between it. It's got to be perfectly 7.5. I'm assuming it's closer to 8.
That's right.
I think I'm going to guess. So the next one says, estimate your root to the nearest 10th. So I'm going to start off with 7.6.
I think that's a really good starting point. And so what you're doing is you're going to multiply 7.6 times 7.6 and see how close to 60 that gives you. And so Miss Powell, look at her doing math without a calculator. Is that not amazing? Woohoo! 2 thumbs up for Miss Powell. Look at that. Look how quick she is.
Okay. Remember when you multiply one decimal place number by one decimal, you count how many decimal places you had in the problem, and that's how many decimal places you have in the answer. Now, my goal was to get to 60, but you have to understand I'm never really going to get to 60, but can I do better than this number?
We might get a little closer.
So I think I'm going to have to jump up.
So again, Miss Powell, 7.6 is an estimation of square root of 60. We know it's between 7 and 8.
Right.
7.6 is closer. Maybe 7.7 is even closer than that.
So I'm going to do it again.
Miss Powell works so good under pressure. Watch this. I couldn't do this. You guys, I would probably go crazy trying to do this in front of you guys.
Now I've got 59.29.
Ah.
That's pretty close to 60, but I'm going to see if 7.8 is better.
And
so
Miss Powell. See, I would never teach you guys to do this. Miss Powell's overkill.
Show at least 2 tests using long multiplication. This, I'm going to see if it's going to be closer. So 56, 60, 0. Now I got 60.64. Do not think this is like those little games that if you go over, you lose. That's not the case. You got to see which one of these is closer to 60. So to see how much farther off, I would take this and subtract 60 off of it. So this is 0.64 away. So this is off from that. Now I want to see how close 59.29 is from 60. So I'm going to take 60, take away 50.29. You can't take 9 from that. So you're going to have to do a lot of borrowing here. 7. So this is 0.7 off. So which one is closer? The answer to 7.7 or the answer to 7.8? And the one with the smallest number, that's the one that would be closest because that's how much, think of it like money. You're either 64 cents over or 71 cents under. It'd be better to be 64 cents over because it's closer. So 7.8 is a pretty close estimate to square root of 60. Now this is when I'd get my calculator back out and just test it. So if I go and I do square root of 60, I get 7.745966692. The calculator is going to give me all of those. So the calculator is going to give me all of those where I'm just asking you to estimate it to the nearest tenth.
All right. Well, that's a pretty good wrap up of how to find an estimation of an irrational number. Again, perfect squares are going to be your friend because they're always going to be rational.
Oh.
Anything that's not a perfect square will be irrational. And so we're going to let you guys go, and we will see you back in the next video. And I can't stop it.
Go to the
Go to the what?
go to Google Chrome. Did you start it? I think you stopped it a long time. I don't know if any of that recorded.
I didn't stop.
I don't think you ever started it.
Well, I know I did because I was on. Oh, and by the way, you don't want to go over because it's going to be 7.7 blah blah
No,
blah.
I messed up. That was 7.84. I did mess up. There it is.